All right, we're going to work on transformations today. Transformation, we're going to take graphs and transform them. All right, the basic or parent functions. You need to know what these functions look like so your work is much easier today. Let's take one at a time real quick. Let's see if I can blow this up. Yeah. The first one's called the identity function, just y equals x. It's just a line that goes through 0, 0, 1, 1, 2, 2, 3, 3. Because all those numbers I just picked, the y and x are the same. 1, 1, 2, 2, 3, 3. Y equals x. Just a line right through the first and third quadrants. The squaring function, also known as quadratic, has an x squared. It is a parabola. The vertex is 0, 0. It goes through 1, 1, and also negative 1, 1. It is a parabola. X squared is quadratic. It is a parabola. The square root of x. The square root function is half of a sideways parabola. Also begins at 0, 0. Goes to the right. Half a parabola. Square root function, half of a sideways parabola. The cubing function. The cubing function, if you have something cubed, this is going to sound weird. It's also a parabola, kind of. It's half a parabola going up, half a parabola going down. But the cubing function looks just like that all the time. Goes through 0, 0, just like everything else has. And half a parabola going up, half going down. Let's keep looking at the other ones. Cube root function is taking the cube function we just looked at and turning it sideways. Look at this. We took that thing right there, turned it sideways, and it goes, it's basically a sideways parabola, kind of. Half of a parabola going this way, half a parabola going that way, and guess what? It goes through 0, 0. So the square root function was just half of a sideways parabola. Where did it go? Half of a sideways parabola. I lost it. I know you're going crazy right now, like, what is he doing? There it is, half of a sideways parabola. The cube root function is 2 halves of a sideways parabola, one going each direction. The reciprocal function, x on the denominator, 1 in the numerator, has a curve in the first quadrant, a curve in the third quadrant. They do not touch either axis. They get closer and closer to both axes, but they do not ever touch the axis. The axes are called asymptotes. And absolute value is the last one. Absolute value is a V shape. Notice, believe it or not, it touches 0, 0. And it is like the identity. Remember, the identity was y equals x. This was y equals absolute value of x. The identity went on down through here. The reason absolute value doesn't go down through there is because it has to be positive, so it bounces back up that way. That's what's a V shape. So you need to make sure you have a good handle on what those shapes look like, so that when you see one, when we transform it, you can just move it really, really quickly. All right, we have about 4 types of translations or transformations. The first is called vertical translations or shifts, and that is this. That is when you add something to the end of an equation or end of a function. If you added a b, you're going to shift it up that far. If you subtract b, you're going to shift it down that far. And I got a picture down here to show you what I mean. Right here, this is the original equation, and that's the one in black right here. It goes to 0, 0, it's x to the fourth. It's a parabola, really wide there. Look what happened here. All they did to the equation was add 5 to it. And look what happened to the graph. From the black to the red, it just got shifted or translated up 5. If you add 5 at the end, it shifts your graph up 5 or translates it up 5. Look at the other case. The other case, it started with the same thing again. Started with just this one, which is the black one. But look what we did down here. We came down here, subtracted 3. So basically, we took the whole graph, shifted it down 3 or translated it down 3. Okay, horizontal. Horizontal is when you subtract d or add d, but this time it's in the parentheses. All right, it's inside. I'm going to say this a lot. I'll say it's inside with the x. If it's inside with the x and it's positive, it's opposite of what you think. If there's a minus sign inside, we're just going to shift it right. If it's a positive sign inside, we're going to shift left. So that part's opposite of what you think. So the number inside shifts it opposite of what you think. Let's look at a couple pictures here. Like this first one, same picture we had on the last slide. The black one is the original. Look what happened here. Look where they put the minus 3 this time. The minus 3 is inside with the x, and so that means you shift it right 3 because it's a minus sign. You always do opposite. I'm going right 3 there. All right, look at the other one. The other one is they put same black picture again, but this time they put a plus 7 inside. Look what happened to the graph. The whole thing got shifted left 7 or translated negative 7. All right, let's try a couple of graphs here. This first one says, graph the following, describe the transformation used from the basic graph. So the first one is x squared Remember x squared, usually I would do this right here. I would say, oh, it's just like this. It's a parabola. It's supposed to touch 0, 0. But this one has a minus 6 outside. It's not inside a parenthesis. So I'm going to go down 6, down to there, put my vertex there, and it's going to do this. And when it says describe, you'll say it shifts down 6. Let's try the second one. The second one here is it's an absolute value. Remember, absolute value usually does this right here. Oops, I don't know why it does that. Absolute value does this right here usually. Now this one says it's been shifted right 4 because the minus 4 is inside, and you go opposite. So I'm going to go right 4 and draw my V. I don't know why it does that, because it does that right there. So when you describe it, you would say it shifts right 4. And the last one over here, it's got both things in it. And remember what a square root usually looks like. A square root function usually starts right here at 0, 0, and is like half a parabola that way. Well, this one, because I have a +2 inside, a -3 outside, the +2 inside shifts it left 2. The -3 outside shifts it down 3. So I'm just going to start my half a parabola down here and go that way right there. So just translations, just shift your graph left or right or up and down, or in that last case, both. All right, reflections. If you have a negative sign in front of your function, if everything changes signs, or if you have a negative in the front, it reflects it across the x-axis. If the negative is the x, if the negative is inside the parentheses with the x, it reflects across the y. And of course, I got a couple pictures down here. The first one is a reflection across the x, because look where the negative is. Here's our original. Come on, here's our original. Look where the negative is. It is in front. It's in front of the whole function, so it got reflected across the x-axis. The graph just got reflected across the x. The second case is, look what happened here. We had this original function, which is kind of a weird-looking function right here, but that's the black one. And look what we did here. We put a negative x where the x's were, or inside the parentheses where the x's were. And what happens is it gets reflected across the y. So that black graph, I hope you can see it here, the black graph does, I'm kind of tracing it again, does this. If you reflect it, all of a sudden the red thing happens. It gets reflected across the y. Don't confuse those two graphs right there. The black one is one graph, the red is one graph. Okay, last one, finally. Vertical and horizontal stretchings and shrinkings. Easy for me to say. Okay, if they put a number in front of your function, in front, and it's bigger than 1, it should say the absolute value is bigger than 1. It is a vertical stretch. If the number they put in the front is a absolute value less than 1, or is a fraction, it's a vertical shrink. It's going to shrink it vertically. Let's go ahead and do horizontal also. Horizontal, the number is inside the parentheses, multiplied with the x. If they multiply a number by your x, and it is, I should say absolute value again, is greater than 1. This is backwards of what you think. If horizontal, if it's bigger than 1, it's going to shrink horizontally. If it's less than 1, means it's a fraction, it's going to actually get stretched horizontally. And I got a picture of each, of course. So here's the one that's been, let's just look. This first one right here, the original graph was this. All right, it's the black one. I changed it and put a 1/10 in the front. Because it's in the front, it's a vertical. And because it's less than 1, it's a fraction, it's a vertical shrink. So I took the black one and just squished it down. What I really did there is multiply all the y coordinates by 1/10. I took a 1/10 of every y coordinate and it shrinks it. The second one is the same function, but I put a 2 in the front. Because it's in the front, it's a vertical stretch. And what it does is you take every y coordinate and multiply it by 2. It makes it steeper. So a vertical shrink will make things flatter. Look at the red versus the black. A vertical stretch will make things steeper. All right, let's do the horizontal. Horizontal, if you look at it, look at the number they multiplied the number inside by 2. Not outside in the front, but inside. And that's a horizontal because it's bigger than 1. It's so different. It's a horizontal shrink. So it kind of squishes your graph inside. It makes it skinnier. All right. Now, just the opposite on the second one. If they put a fraction inside, it's backwards of what you think. It's actually a horizontal stretch. So if you look at the green graph in that picture, they took the black graph and stretched it horizontally. That's what that does. Again, the first one squishes it horizontally or shrinks it horizontally. The other one stretches it horizontally. Okay, based on the graph below, graph each of the following. I don't know if I'm going to try to get this all on one graph. The first one, the 2's outside. When the 2's outside, that means it's a vertical stretch. So I'm going to take every y coordinate and multiply by 2. The first one, 0 times 2 is 2, not moving that one. This one, 2 times 2 is 4, so moving that one up to 4. This one's 0, it stays. This is negative 4 times 2 is negative 8. It goes all the way down here to negative 8. That's 0, it stays. So what the 2 is going to do is going to make the graph look like this. It's going to stretch it this way. All right, it stretches it vertically. Let's see if I can erase that now. And yeah, okay, so now I'm doing this one. The 1/2 is in the front. Because it's in the front, it's a vertical shrink. So I'm going to multiply all my y's by 1/2. 0 times 1/2, that's still a half. 2 times a half is 1, so I'm going to go up to 1. 0 is still 0. Negative 4 times a half is negative 2, and that's still 0. So if I connect my dots, it looks like that. So it got shrunk vertically because the 1/2 was in the front. One more here. This time the 2's inside. Because the 2's inside, it's a horizontal stretch or shrink. And because it's 2 and it's bigger than 1, it's a horizontal shrink. So because it's horizontal, I'm taking my x's. And I'm going to do this. I'm going to take that x right there, and I'm going to take half of it because I'm shrinking it by 2. So I'm going to go to 2.5 right there. That's close to 2.5. My second point up here, that's at negative 2. So I'm going to just go to negative 1. This is 0. It's not going anywhere. This one's at 2. It's going to go to 1. This one's at 4. It's going to 2. So really, I'm doing the reciprocal of what's in there because I'm shrinking it by 2, which means I'm shrinking it in half. So my graph now is going to look like this. Boom. And then my little parabola is going to go right there. So what happened is my graph got shrunk horizontally. When you do horizontal, you're dealing with the x coordinates. When you do vertical, you're dealing with the y coordinates. Last slide. Part of your homework is just going to say this. Just describe how this graph can be obtained from the parent graph. Well, the parent graph is f of x is just absolute value of x. I don't know why I put a parentheses right there. It should be absolute value sign. That's the parent graph. So what changes from there to there on the graph? Don't have to graph it, just got to describe it. First of all, there's a 3 inside multiplied by the x, which means that's a horizontal shrink. Horizontal shrink. And you got to tell by how much. I'm going to put by 1/3 because it's a 3. They always do reciprocal with horizontal. And there's also a -4 outside, which means it's been shifted or shifts down 4. All right, so that's a lot of stuff today. It really is. We'll see how it goes tomorrow as far as how quickly you pick all this up. Kind of a lot of info, not hard info, just a bunch of it. And I know you won't be surprised, but I got a good gestures to get you through tomorrow. Hopefully it helps. And some of the best ones we got all year, to be honest with you. And I'll see you then. And that's it.